In a previous video, I showed you how to deploy Fortigate on Edge so that your Fortigate will be internet accessible and you would use your Fortigate for services that require internet visibility like VPN connections or client VPN. And for this, once you open your Fortigate to the internet, there is a risk associated with this step. And in this video, I want to show you a few tips and tricks so you can secure your Fortigate instance from attacks and prevent unauthorized access to your device so you can make sure only trusted users are able to access the device for legitimate reasons and nobody else are able to access the device. Let's see how we can do it. I want to use my GNS3 lab here to emulate a Fortigate connected to the internet and deploy it on the edge. As we see in here, our Fortigate has two interfaces. First, our port 1, which is connected to the internet, emulated inside GNS3 with this internet cloud. And we have another interface that is connected to our LAN network or our private network. In this case, the firewall is the gateway with the IP address 10.10.100.1 and it's a /24, so it has 256 IPs. And our private LAN contains an Ubuntu client that is running 10.10.100.100. So it's part of this LAN network and it reports to the gateway that is managed on the firewall on port 4. On the other hand, we want to emulate the internet traffic by adding an internet client that is outside of our network. And we want to see what are the best practices and tips so we can secure this setup. Let's start with tip number 1. Never allow HTTP management access to your firewall from any place. The reason for this, HTTP traffic is not encrypted. Therefore, anytime you send your username and password to the firewall, it's not encrypted at all. Anybody can spy on the network and get your user login. And the only exception for this is the trial virtual machine that we use inside the lab because they do not support HTTPS, which is the encrypted protocol. So I want to show you now what is the risk associated with this. So assume this scenario, you are going outside with your work laptop and you want to access your Fortigate so you can fix something quickly on the go. And you join from public Wi-Fi, let's say you are on Starbucks and you use your client here to communicate with the firewall over the internet. We can see here that our firewall is reachable on the IP address 17.0.0.1. This IP address has HTTP access and SSH access open. If we want to verify this, let's open the CLI, go under config system interfaces, and let's do a show. We can see in here port 1 has 17.0.0.1, has ping HTTPS, HTTP, SSH, and although it does say HTTPS, but the trial VM does not support HTTPS, so this is just the software, it doesn't mean anything. And the same applies to our port 4, it accepts ping HTTPS, SSH, so we know for sure that both ports accept HTTP and SSH connection. So now let's go ahead and close this. Let's say if we open this client right now, and from here let's put the IP address 17.0.0.1, it's already letting us know that this connection is not secure and the login can be compromised. So this is a browser alert already alarming us that there is something not properly set up in here. Now we can also go ahead in our GNS3 and try to capture traffic from here. This is something anybody sitting in Starbucks public Wi-Fi can do, and therefore they can see this data. So if we try to start capture, this will trigger the Wireshark, which is a client for capturing network traffic. Now we are directly spying on the Wi-Fi network that we are supposedly connected to. So now if we go back to our client and put our login information in here, try to log in. So now we are inside the device, but look what the user is able to read using the Wireshark. We can stop this so we don't get any more data. And we can see here all the HTTP traffic is unencrypted. You can see things like the user agent. You can see which IP address is being used and all kind of information. But the worst part is if we go back all the way until the beginning of the session, we can see here once the handshake was completed, our login check page was posted. So if we try to go ahead and try to follow this TCP stream, we just go ahead and click follow TCP stream. This would show us all the data in clear text, like the HTML data for the GUI that we are accessing. You can see here all the firewall related URLs, all the metadata. But the more important, we can see here that the username and password are showing for the user to copy and get access to your device from the internet because you are using HTTP protocol. So if you are using the Fortigate in production environment or from a workplace, you should make sure that HTTP access is not enabled, not even HTTP redirection. You're better off just disabling HTTP. And to be able to disable this HTTP access, you can simply go ahead under config system interface and we can edit the port that we are interested to remove this access from, let's say port 4. And in this case, if we do a show, this is our allow access statement. We can copy the whole thing and just remove the HTTP part. And this way, once we go ahead and do next or end, this interface no longer has HTTP access. Let's do a show and verify one more time. Now we don't see HTTP access in here. So this interface would not accept HTTP traffic from anybody for management, but we are forced to leave this one for now so that we can use our FortiGate on this lab. But for normal devices, make sure this access is not open, especially to the internet. Now let's get to the second trick, which is Trusted Host. And Trusted Host is a security feature under the users menu that allow you to define which IP addresses are the users allowed to log in from. So let's say in this case, we are using this interface and it's exposed to the internet and we want to keep accessing using HTTP for whatever reason. Maybe we are using this lab and we want to access from the internet, but we still want to secure it. We can use the trusted host to prevent users from accessing the device from unauthorized IP addresses. So this assuming we know the IP addresses where our users are coming from, or maybe we have a network that is dedicated for our company, we can simply whitelist those IPs and block everybody else. So now let's see how we can implement this using our admin menu. Let's go ahead and go back to the main screen and we need to go into config system admin. And if we do a show, this will show us all the administrators are defined on this device. We only have our only one admin account, and this is the password encrypted format. And this is the account profile, which define our super user as full access user. And this is also the VDOM in case we were using virtualization. So the way we can do this is we can first go into our user, and it's called admin in this case. We do a show one more time, this will show us just the admin settings inside. And then we're going to use the command set trusted host. We have multiple places we can put multiple networks. You have 10 different slots, you can put different networks and you can define whatever networks you are allowing to access the device. We can put set trusted host 1, and then we can define the network, which is 17.0.0/23. This is our first network for our internet. And our second network in this case, we can put set trusted host 2, and then we can define 10.10.100.0/24. So now only these two networks are allowed to log into the device, no matter where you're coming from. Those are the internal IPs and those are the external IPs. So let's do a show one more time, and now we see our two statements got added in here, our trusted host 1 and our trusted host 2. Now this is not saved yet, we need to make sure we do an end. Now we are back to our main screen, so those settings got saved. Also make sure that if you have multiple admin accounts or multiple users listed in the admin menu, make sure you add those statements on every admin accounts, not just this one. Otherwise it's not gonna work. Now let's temporarily add the port for HTTP access back so we can test the access from the internet using the trusted host. And then we can go back. So now if we open back our client and if we try to access again, we still have the access because our IP address 17.0.1.254 is inside our trusted host statement, and same for our private client. And if we try the IP address for port 4, which is also have HTTP access enabled, we are also able to log in using this interface. Now let's go ahead and test removing this IP address by going into our admin again and editing our admin. Let's say we want to switch this statement from 17.0.0/23 to a smaller subnet that would not include this IP address. So that would be 17.0.0.0/24. This is only half of the subnet, and in this case it will not include this IP address. So now once we go this and we do next to save it, if we go back to our client and the same IP address. If we try to refresh, it's gonna time out because the trusted host is not recognizing this IP address, and this will help prevent a lot of noise because these clients out in the internet will not know that this client actually is alive or responding to anything because all they see is just timeout. Also, if we try to come here and if we try to do something like SSH to the firewall, we can do SSH admin, which is the username, and the IP address of the firewall was 10.10.100.1. In the same way, our SSH will not be able to pick up the connection and we will not be able to access the device using this IP address. Now, if we try from our private client in our private network, which is this IP address 10.10.100.100, this is still part of the trusted host statement. So if we try to access 10.10.100.1, we are still able to access, but also if we access by using the IP address 17.0.0.1, we are also able to access. From our terminal, we can also try to SSH to the public interface. We are able to get to it. And we can also do on the other interface, which is 10.10.100.1, and we are able to SSH from our internal client, but the other client is not able to see this traffic at all, and that was using trusted host. Now the next step I want to show you is to change the default ports on the firewall, as the firewall comes with the default ports configured for HTTP, HTTPS access, and also SSH access. Those use the ports 80, 443, and 22, which are the default ports that a lot of online scanners will always try to scan, and therefore you want to change your ports so that you make it harder for them to find out which service are you running and which port by choosing a higher port number that is unusual or not default, and this way you are kind of masking your connection rather than making it open to the default port. Let's take a look back at the Wireshark example. When you use HTTP port, you send it on port 80. This is the default port. If there was encryption enabled, it would be enabled on the default HTTPS port, which is 443. And for the SSH, it was also using port 22, which is the default SSH port. Now the Fortigate allow you to change this port to something different. And the way you do this, you go into your CLI, and this is an option that is listed under the global settings. So first we need to go into the global settings using config system global, and from here we can set multiple parameters to change our port. Our first parameter that we want to try is called sport, and the S stands for secure, and the port will belong to the HTTPS access. So we can say set admin-s port, and if we do a question mark, this will ask us to put any port, and the default is 443. We can choose any number, preferably above 1024, because those are the common ports that most of the online scanners will test. But if we choose something like 40,000, for example, we can access now the Fortigate on HTTPS using port 40,000. And to be able to demonstrate this, since this KVM image does not support HTTPS, I want to use my physical device as example, as I set this up using port 8443 as a mask for the HTTPS access. So if I try to access 192.168.1.99 just per IP address, this will try on HTTP. Of course, HTTP is not enabled. If we try using HTTPS by adding HTTPS to the beginning, it's also not going to respond. And the only way you would know that there is something live in there is to go ahead and put the port number in the end like this. So this is the custom port that I set, 8443. And this way, once I put this in, it allowed me to go through into the firewall and be able to log in. So in case you allow HTTP redirection or anything of that sort, you're literally giving the hackers a way into your firewall, because now they don't need to guess, they already been redirected here automatically. So they would know you are using port 8443 and they don't have to guess anything. So the best way is to disable HTTP redirection and change your S port so your HTTP access is masked. Now we can do the same for SSH. As we seen, we were able to SSH directly to the IP address using the default port 22, and we were able to get access to the firewall. In the same way, we can come here and say set admin-ssh-port, and in here we can also put a question mark. The default value is 22. We can put a different port. So for example, let's say port 40,001, and now we can do an end to save both settings. So now if we try again to SSH to the IP address, I'm no longer able to SSH on the default port because this is no longer listening or no longer accepting new connections. And now the only way to SSH to the device is to put SSH admin at the IP address of the firewall. Let's say we want to use the 10.10.100.1, but we have to put a flag -b to define the port and then define the port to 40,001. And this way we can log into the firewall SSH using the custom port. And if someone tries port 22, they will feel like there is no SSH port open and they will not try to brute force your device. Now, assuming you really need HTTP access to still enabled, maybe you're doing this for a lab, or maybe you are adding trusted host and other security features that are required to work with HTTP unencrypted traffic, you can also change the default port for HTTP from 80 to something different. In this case, we can just go under config system global again, and finally put the command setadmin-port, and if we put a question mark, the port is 80. So we can change the port from 80 to maybe 50,000. And once we do end, this setting now has been saved. So now if we go back to our client and try to access the same URL we used before, now it no longer works, and the user actually have to define the custom port for HTTP. And now if we try to log in again using the custom port, now we are able to access the device normally using the custom port, but anybody trying port 80 or the default port or not defining this custom port in the end will not go anywhere. Now our next step to remove ping access from the internet interface, as a lot of services depend on ping to determine if you are alive. And if you don't run any services that require your firewall to be pingable from the internet, you can simply disable this ping access to remove a lot of the noise coming from the internet to your WAN interface. So in this case, we are using port 1 to connect to the internet. We can go ahead and do config system interface, and we can do edit port 1, and we can do show. Right now we have ping access enabled. Now I'm going to keep a ping running so that I can monitor this access as I change it. And from here, I just want to come here and copy my allow access again and save it. But in this case, I want to remove the ping access first. And now once I do next, our interface will no longer be responding to the ping request because all these packets will be dropped. And that's an effective way to remove a lot of the noise by disabling ping access from the WAN interface or from the internet interface. Now the next step to secure your Fortigate on the edge is to set a lockout threshold and a lockout interval. By default, the firewall will allow you to enter only 3 login attempts, and if you put your password wrong for 3 times, it will block you for 1 minute, and then it will reset again after just 1 minute, which might not seem enough for current level of attacks because someone can write a script that will re-trigger every 1 minute and try 3 more times, and maybe in a few days they are able to pick up on your password. We can try to emulate this by going back into our access, and let's try to put any bogus password, like someone is trying to guess your password. This is our first attempt. This is our second attempt. And after third attempts, it's gonna say too many login failures. Please try again in a few minutes. But it's not a few minutes, it's just 1 minute. Now the way we can change this threshold, we also need to go back to our global settings. I want to go back to config system global. Now we can simply do something like show. This will show us all the global system settings, but because there is a lot of them, we can actually put here a filter using grep, and we can do like grep lockout. This is the keyword that is used to define this. And because it's not showing anything, that means we do not have any custom value. It's still using the default value of 1 minute and 3 attempts. Now if we try again, after 1 minute here, we are able to access again. Really easy, but this can be improved. So let's say we want to decrease the number of the attempts that the user can enter before they are getting locked out. This value can be between 1 to 10, and it's by default 3 attempts. So we can put something more conservative or more restrictive, but you have to be careful because 2 times or 1 time can be brutal if you just put a typo. But let's say we just want to explore by changing it to only 2 attempts. So you can do set admin dash lockout. You have a duration and you have a threshold. So if we put here a question mark, the threshold is set by default to 3 login attempts, and you can change it between 1 and 10. So I want to change it to 2. And also for the time, I want to change the time to something longer. So I want to do the same command, but instead of threshold, I want to put duration. And if I put the question mark, as we see in here, the default is 60 seconds, but you can put it as much as this number. So let's say we want to put a brutal lockdown time of 8 hours. So I want to change it to 86,400 seconds. And now if I do end, let's try to emulate this by refreshing. Now, this is my first bogus attempt. This is my second attempt. And now it blocked me only after 2 times. But now if I come again in 1 hour, 2 hours, it's not gonna allow me at all. This message will not disappear before whole 8 hours. So this will block a lot of the brute force attacks in your device, and it will help you secure your Fortigate on the edge. Now before we move forward, since I blocked myself for 8 hours, I'm gonna go ahead to the admin account again and remove the trusted host that I added earlier so that I can use my internet client to access for the next step. And the next step is to use a custom admin name. A lot of people miss this step, and a lot of applications are programmed to use root or admin or the default usernames that are usually accounted in the device. In this step, I want to show you how you can change the admin name from admin to something different so that you make it really hard for people to even try to brute force you as well, and reduce the chances of risking your device to the outside world. Now, as I logged in with my admin username as usual, I can go ahead to System, Administrator, and from here, this is my admin account that I'm logged into right now. And as you see, if I open my admin account, I cannot modify this value yet. So the way we can modify this, we have to add a new administrator first so that we make sure we don't lock ourselves down. So this one, I'm gonna call it not typical username, and this will be my username to the device. For the password, of course, is gonna be 123. And for the administrator profile, this is where we choose, is this an admin account or this is a read-only account? The highest privilege in the device is super admin. So we want to go ahead and choose super admin for this one. And we are also able to restrict login to trusted host using the GUI, the same we did from the CLI. We can put the networks in here and add additional networks as well. So now we have our second username with the super admin profile. Now we can go ahead and log in from our admin account because we are not able to change the username while we are logged into the same name. So I'm going to use my newly created administrator account. And in this case, once I log into the firewall, so now we can go back to System Administrator. And now we see our old admin account. We can directly delete it from here, or we can go ahead and edit and change the username from admin to something else. Let's say we want to say not admin. Now if we save, now our admin account is masked and nobody can get access to it. If we want to only stick to the one admin account, we can directly click here and just delete this one. And now we no longer have the original admin account, we just have this not typical username, and it's going to make it harder for the hackers to guess your password. Now for the final tip of this video, I want to also show you how you can put a legal message warning users not to access the system if not authorized to do so. And this is a legal binding statement that you can put in your firewall. So this is very important for companies and businesses as they need to put a legal message on their devices to make sure nobody mess with them and that there is a legal consequences for doing so. Now this is something we can simply do better on the GUI because of the texting format for it. So we can go ahead in replacement messages. So first let's try to change to extended view so we can see everything. And under admin we see two different options. There is a pre-login and post-login. So the pre-login shows up before the user login to the device, and post-login is showing for the user after they are successfully logged in. So let's start by the pre-login, and this is pretty much all we need. And there is already a pre-saved message saying this is a private computer system. Any unauthorized access is prohibited and subject to legal consequences. We are okay with that. This is good enough for our case. We can save this. Now finally, after we added our pre-login banner, or we agree to the default one, to be able to enable this feature, we need to go into global setting again, and we only need to put one command, which is set pre-login banner enable. And once we do end, this way our setting has been saved. Now let's go back to our client. And this time, instead of the normal login screen, if we try to refresh, the user will be given the login banner with the legal message in the beginning. If the person trying to access your device, click accept. In this case, they are legally binding to this specific agreement, and therefore they will be scared to take any action. To make sure this is a really serious message, and make sure there is no welcoming messages or statement whatsoever, to make sure the users are taking this seriously. And those were my tips and tricks so you can secure your Fortigate instance and minimizing the risk to your device using all these tips. Thank you for watching.